So this is day 2, gas laws. Today we're going to actually get into the effects and how you can calculate the differences between pressure, temperature, and number of particles. So just a quick reminder, kinetic molecular theory. There are 4 variables that are generally used to describe a gas. They are pressure, and we're going to measure those in kilopascals, millimeters of mercury, or torr, and atmospheres. Volume, we're going to be using liters or milliliters. Temperature will always be in Kelvin. Whenever you think gases, think Kelvin. And the 4th one is the amount of moles, or the number of particles. The effect of adding or removing gas. When an amount of gas is given, in a given volume is increased, the pressure increases. So the more gas we have, the pressure will increase in a set volume. If you double the amount of gas, you're going to end up doubling the pressure. So 2 times the amount of gas, you'll have 2 times the pressure. More particles means more collisions, which means more pressure. Remember, pressure is just the number of collisions on the side of our container. It's a direct relationship. If a number of particles doubles, the pressure doubles. If we change the volume of the container, when volume of a gas is decreased for a given amount of gas, the pressure will increase. Smaller volume, greater pressure. If we decrease the volume by half the volume will have twice the pressure. This just makes sense because we have the same number of particles colliding with the side of a container, but our container is much smaller, so those particles are going to hit the side of the container more often. Particles are closer together in a container, which means collisions, which really means pressure. It's an indirect relationship. If the volume is halved, the pressure is doubled, and vice versa. So, real-world application. When you're opening soda cans and pop bottles. Soda cans or bottles are usually opened slowly because we've learned that popping them open too fast causes it to fill up and spill all over the place. When you open the cap, the gas is suddenly able to increase its volume in order to decrease the pressure inside the can. Shaking a carbonated beverage causes the gas bubbles to mix with soda, and before some of the gas can settle out, you've got quite a mess now, don't you? Factors affecting gas pressure. The effect of changing temperature of a gas. When temperature of a gas is increased, the particles have more kinetic energy, and the pressure will increase. Doubling the temperature will double the pressure. The particles will move faster when heated and strike the walls of the container with more force, so the pressure builds. It's a direct relationship. If the temperature is doubled, the pressure is doubled, and vice versa. Another real-world application, aerosol cans. A gas in a sealed container can generate an enormous amount of pressure when heated. That's why all labels on aerosol cans say do not store above 120 degrees Fahrenheit. Even empty aerosol cans still have some gas in them, so they will explode if thrown into a fire, and we talked about in the class yesterday. It's also wise not to store cans at a temperature that will freeze the substance. Freezing causes the substance to expand and could puncture the can.